Well, we are back with the daily space weather, despite ongoing discouragement from YouTube. We'll talk more about that later in the video. Check out the massive prominence rising in the northeast. We'll talk about it, sunspots, solar flares, cosmic rays, and lots more on today's video. And congratulations on realizing the existence of the Smash News Network least busted name in news. This is the past 24 hours from SDO. You're looking at ionized helium and ionized iron. Here's the northern hemisphere. You may see a huge crown prominence happening there, a large solar filament there suspended by magnetic fields over the north heliographic pole. Also, check out that huge prominence in the upper left there. That's the northeastern limb. And here's a close-up of that north crown prominence. There's also a filament on the below the Earth scale there. So two large filaments hanging out near the north heliographic polar region. Here's the equatorial area. Again, dig that massive prominence in the northeast. Some huge filaments in the Earth-facing portion of the solar disk, to say the least. And when it comes to space weather, we say the most. Here's the southern polar region. We've got crown prominences down there also, and you can expect these things to only increase for the next approximately year, folks. You can expect another nearly 2 years of similar levels of activity. It's going to be exciting stuff. You may see a prominence up here also happening. That one actually happened while we did yesterday's live stream, which, by the way, was demonetized. It has since been remonetized. Here is that massive filament in the northeast. It's big. It's highly unstable looking. We'll be keeping an eye on it. And when I say eye on, well, pardon the pun. I think it may be safe to state that that is indeed a money shot. We've got more spectacular imagery of the closest star for you here coming up. Next on tap is the SDO intensity gram. We've seen a decline in solar activity since yesterday. One new sunspot group ought to get a name here. This one, I don't think this one down here as well. I think that one did get a name. But this one up here now just recently formed in the past few hours, actually. So there's one closer to the equator there. You may be able to see the magnetic fields of that. This is the SDO colorized magnetogram. And we'll show you close-ups a little bit later in the video. Next is the volcano rundown. So Kilauea now back on the list, by the way. And if you want to watch Kilauea erupting live, check out the Two Pineapples channel on YouTube. Two Pineapples. Looking to get them on the channel and maybe vice versa at some point in time. Doing great live coverage of Kilauea. So anyway, Abico is erupting on Paramushir Island in an explosive fashion. That's a 10,000-foot ash plume produced by Abico. Mount Mayon, flight level 100, 10,000-foot ash plume from Mayon on the Philippines. Krakatau also exploding, flight level 040. It's a 4,000-foot ash plume over the Sunda Strait, the daughter of Krakatoa. Krakatau. Semeru also erupting, flight level 130 as it explodes. It's a 13,000-foot ash plume. And Kilauea, go ahead, folks, say it with me. Halema Uma'u. You know you want to say it. George Lucas did not make up that name. Halema Uma'u Lava Lake. Yeah, you could say it. Anyway, the effusive eruption continues there. It seems to consist of 2 to 3 lava fountain clusters and several independent ones characterized by the continuous spattering, ejecting hot, fresh, and plastic lava clots and lava flows. Hawaii, new real estate, continues to get made on the Big Island. Fuego in Guatemala exploding, flight level 145. It's a 14,500-foot plume of volcanic ash as Fuego explodes in Guatemala. Revenador exploding in Ecuador, flight level 160, 16,000-foot ash plume and 23,000-foot ash plume over Peru as Sabancaya explodes. It's a flight level 230. Next, looking at global seismicity. Things have been pretty calm here. Not a lot of quakes and no big quakes over the past 24 hours. We'll do a rundown reporting quakes of a 5 magnitude or higher. Indonesia had a 5.6 at 17:04 Universal Time yesterday afternoon. There is the location of that, the aqua dot on the map. 5.6 magnitude quake there. And then, let's see, only about 35 minutes later, a 5.1 strikes Colombia. The opposite side of the Pacific Ocean there. The Mid-Atlantic Ridge had a 5.1 really far south near the Antarctic plate boundary. That was at 4:02 this morning. Papua New Guinea had a 5.2 this morning. That was at 7:32 Universal Time. And southwest of the Loyalty Islands, there was a 5.7. Those are the quakes of a 5 magnitude or higher. And let's get back to space. Space, a frontier. These are the 24 hours of images from SDO in 171 angstroms. We've added 211 angstroms to show you some additional depth and coronal holes. We'll get to that in a moment. These coronal holes, we can expect to see a high-speed stream from one or both of those by week's end. So on Saturday, actually. Saturday by midday. In fact, it might even show up as we make our video on Saturday. Expecting a coronal hole high-speed stream. I don't know why you haven't heard it on NOAA, but you've heard it here on the Smash News Network. Least busted name in news. The 10.7 centimeter radial flux has dipped to 167 solar flux units. And there is the one-year chart of the radial flux. It is represented by that black line. The red line below it is the sunspot number, which you can see has crossed the threshold there. I think several sunspots never got counted. I think the sunspot number should have gone over 200 here most recently, but who am I to count sunspots? I don't even really try to do it, but there were several sunspots that never got names, that ought to have gotten names. I'll just leave it at that. Space Weather Enthusiast dashboard here, forecasting a little geomagnetic unrest later in the day today. I have no idea why. I'll just leave that there. That's NOAA's forecast, a little geomagnetic unrest between 18 and 2100 Universal Time today. We are expecting a coronal hole high-speed stream to show up sometime by about midday on Saturday. Next, Earth's magnetic moment from space. There's our geospace magnetosphere movie for the day. That's the past 4 hours. And things are geomagnetically calm. As you can see, the plasma around planet Earth here trying to reach static equilibrium with higher pressure in the magneto tail side. The sun would be on your left in this imagery. And you can actually see it starting to equalize. Here's the last 4 hours of Earth's magnetic moment from the ground. We show it daily on the channel because people are very frightened by hack frauds on YouTube telling them that the Earth's poles are going to flip. Do you see any quadrupoles or hexapoles or octopoles or anything like that on the map? What's that? No? Yeah, we don't either, which is one of the many reasons we don't think Earth's poles are going to flip. That's the last 4 hours of Earth's magnetic moment from the ground, geomagnetically calm conditions. KP index is currently at 1.66. Again, geomagnetically calm conditions. Let's move to the real-time solar wind next, which is slow and low. So not only is it slow, it is also quite diffuse here. Solar wind density here, about 4.2 protons per cubic centimeter. Solar wind speed only 337 kilometers per second. That is diffuse and slow solar wind. There are the GOES magnetometers, and you can see those. You can expect to see those get a little bit more jagged looking on Saturday when the coronal hole high-speed stream or streams arrive. At the moment, pretty smooth there. And let's move to the heliospheric current sheet. So here is the heliospheric current sheet. This is depicting magneto. It's depicting the polarity of the plasma in the solar system right now. And we do have a sector boundary crossing here, rapidly approaching. We expect that to arrive by tomorrow's daily space weather video. So you can see that sector boundary crossing there. That's the point where the green turns red. And it's not even at stereo A yet. But as you can see, the field lines are all jumbled up in this strong magnetic field orientated plasma here, right here. So this South Pole current sheet could snap through quite quickly. But the most important feature is this North Pole coronal hole, as it is still hanging out there. at the North Heliographic Pole. And when this channel talks about solar cycles, we are not full of crap. However, my theory as to the mechanism that underlies solar cycles is crap. Yes, C-R-A-P-F. And our Gold Smash Team members may already know what that means if they've simply read the posts on the Smash Team site, because we've released that information before fully publishing the paper. Anyway, here is the line of sight field plot. Again, sector boundary crossing. You can see the B field there. Sector boundary showing up from the east. Here's our coronal hole line of sight field plot. And again, we've got, like we said yesterday, there are some South Pole oriented coronal holes rotating in here. Let's bring up the last image. There you can see some red showing up there trans-equatorially. Those are the most geo-effective type of coronal holes. And let's take a look at those from SDO. So the last images we showed you were from SDO 211 plus 171 angstroms. Let's subtract the 171 angstroms. And there's just 211. We've got these quite symmetrical coronal holes that are rotating through here. Again, expect a high-speed wind stream, actually a high-density stream showing up about midday on Saturday from those. And then expect the high-speed stream portion to show up Saturday night, maybe early Sunday. And of course, you can see those South Pole coronal holes there showing up as well. And it's time to talk sunspots and chew bubblegum. And I'm all out of bubblegum. So, okay, 3331 got named. 3332 will be the next sunspot. It's right there to its northeast. It's pretty well defined. It's also pretty small. I'm not sure if it's alpha or beta class, but we'll show high-res imagery of that later in the video. And let's take a look at sunspots in some detail here. Once again, from the ever-popular SDO. So here's the past 24 hours in SDO magnetogram, plus 171 angstroms, to highlight the magnetic fields and the plasma of the lower corona. That's that loopy-looking plasma that you see there, aligning to strong magnetic field lines. If they look like the magnetic field lines that you may have seen in junior high science class when you sprinkled iron filaments on a piece of plastic above a polar magnet, well, it's because the plasma is aligning to the magnetic fields. Great imagery there from SDO. And let's subtract the 171 angstroms to show you, well, it's a little bit of degradation here, although mostly stagnant. Not a lot of changes happening there, as you can see with that very high detail view of polarized light using the Zeeman effect to determine magnetic field polarity. Let's get rid of that entirely and show the SDO continuum one more time at this same zoom level. That's the past 24 hours SDO continuum. Again, one new sunspot down here. Besides that, things mostly stable here. I don't see a lot of other changes, and if I'm missing something, let us know in the comments. We do read all comments, and thanks to everybody who leaves comments. If you're new to the channel, congratulations on realizing it exists. Don't forget to press subscribe, notify, press the share button. That helps us to fight back against the ridiculous demonetization, censorship nonsense for absolutely no viable reason. The next thing we'll look at is solar flares and energetic particles. Let's take a look at the data first. And there is the GOES proton flux flatlined. So only one large flare yesterday. It happened about 15 minutes before our premiere at around 46. About 1146 was actually the peak flux there. It was about an M5, a little under an M5 class flare. And let's take a look at their wavelengths. There you go. There's 94 plus 131 angstroms. There's the equatorial zoom. Then the most active flaring region has been down there in the lower left, the southeastern limb. So here's a close-up of that sunspot. And that M-class flare appearing right at the beginning of our video there. The likelihood of large solar flares is very, very high, folks. Why? Because, well, there are magnetically complex sunspots, and lots of them on the Earth-facing portion of the solar disk, period. So them's the facts. Them's the facts, folks. And let's do a cosmic ray update. So cosmic rays qualify as space weather, in my opinion. If you disagree, let us know in the comments. So here we're looking at cosmic ray. Cosmic rays are relativistic particles coming from typically outside of the solar system. Cosmic rays are super important in that they are inversely proportional to the sunspot number and the 10.7 centimeter radio flux. In other words, when the sun is active, we see low amounts of cosmic rays, and when the sun is inactive, we see high amounts of cosmic rays. So it's, in my opinion, a super important feature of space weather. Here's the cosmic ray report from Apatity. The past 30 days featuring almost completely flat levels there. They went up, they came back down. The last 30 days at Apatity were flat when it comes to cosmic rays. Barentsburg, looking like a little similar graph there, although a little uptick in the past 30 at Barentsburg, complete with some missing data. We're going to go all around the world to look at cosmic ray monitors. Next is Athens, Greece. So going much farther south here, there's the Athens neutron monitor. A small uptick over the past 30 days at Athens when it comes to cosmic ray flux. That's another neutron monitor. Whoops. We won't talk about doing the math yet. Next, Mexico City. A tiny uptick there, almost flat for the past 30 days at Mexico City. Similar graph, making all the data looking like it's corroborating each other. Next, Oulu, Finland. Probably the best cosmic ray monitor in the world, as it goes all the way back to 1965. And you can see the solar cycles here. This is a solar maximum, solar maximum, solar maximum. And then, of course, solar minimums occurring here when we see higher cosmic ray flux, the highest of which we saw back around 2010. Anyway, at Oulu, a slight uptick in cosmic ray flux over the past 30 days. We'll also show the farthest south locations we can get. DOMB Antarctica, a small uptick there. And DOMC Antarctica, a small uptick in cosmic ray flux there. Maybe no surprise to people who are Gold Smash Team members. Now, as far as people who are claiming that we don't live on a spinning ball, those flat earth types, I recommend telling those and all the rest of the herp-derps on the internet that are arguing with you about the most ridiculous things ever disbelieved by mankind, tell them to do the math. I mean, we've created this handsome design featuring the SDO 171 angstroms wavelength, and it commemorates the day that we made it. The sun was pretty active that day. I thought it was a pretty sweet image. So do the math, and our equation is 8 equals capital D. There we go. That's a little bit more picturesque. 8 equals capital D, folks. Do the math. If you think you're quantum entangled with things that you can't measure, I suggest you take physics. If you think mankind controls the weather, I suggest you take physics. If you think the universe is electric, or that plasma cosmology is a viable thing, I suggest you take physics. Enough said. Do the math. 8 equals capital D is today's featured product. Available via links below this video, as well as on the homepage at smashomash.com. So welcome to the Neo Renaissance. Help us out with clicks if you're unwilling to pick up some gear from the merch shop. This video does contain paid sponsorship / promotions as well, which we will cover later in the video. Let's see what's going on overhead at Lehigh Valley. That's the current situation. We've got a setting gibbous moon over there in the southwestern sky, and a lot of smoke, which we'll get to in our meteorology segment. First, a solar system forecast. This is where things are now. There's where things will be on the 15th. Shout out to all my astrologers out there. That probably means something. We'll have a crescent waning moon by then. And let's take a look at coronagraphs next. So there are yesterday's coronagraphs. You can see some CME activity indeed going on. Is it earthly directed? Well, I don't think so. I think it's going to miss Earth to the west and the east and the northeast. So let me just break that down. This is the east and this is the west. Why is that? Because space weather, like sunspots, they rise on this side and they set on that side. In other words, that's the way the sun orbits, yes. The east and the west. The east would be your left. The west would be your right, where activity sets. No halos there. Those CMEs do not appear to be earthly directed. CME stands for coronal mass ejections, by the way, if you're new to the channel. Here are today's coronagraphs, an additional 39 frames. And if any of those are earthly directed, they are very stealthy. There could be some components there that are earthly directed, so let's take a look at some more imagery here. There's a brief look at Soho LASCO C2 plus C3, which is located on the Soho spacecraft. And let's just take a look at today's coronagraphs here. I just want to briefly pause these. I think there's a powerful event on the opposite side of the sun here. So there's 6 o'clock this morning. Now, there could be some Earth-directed components there. We'll hope there are. We will hope there are. So here's the view from stereo A also. We'll just show this to get some additional data here. Stereo A located on the left. Soho LASCO C3 once again on the right. And let's bring this to about 6 o'clock. Looks like multiple separate coronal mass ejections happening there. There could be some Earth-directed componentry. Again, let's hope. And what do we got? I suspect it's on the far side of the sun as I see some bright flashing. So let's switch to our coronagraphs here. We made some custom coronagraph images, as you may have become accustomed to seeing on the channel. There is the past 24 hours featuring SDO 193 angstroms and the Soho LASCO C2 and C3 all synced up. So I do see a little bit of plasma moving around here. When you zoom in a little bit closer, you might be able to see that as well. It's all coming from this area down here. So there could be an earthly directed component to that. That's good news for space weather types, aurora chasers, and so on. You could expect that to arrive late in the day on the 11th. So on Sunday night, we may see some aurora. I wouldn't expect it to be major, as it's not a super significant coronal mass ejection, and it might be completely on the far side of the sun, but I do see some motions happening right from here. So I suspect that plasma is earthly directed. Again, expect to see a coronal mass ejection impact Sunday evening. Now, this may have coincided with a massive event on the opposite side of the sun. Sometimes you see fairly general events going on, where you'll see a thing happen on, both limbs at the same time, roughly. Sometimes, perhaps, the ripple effect, as transverse waves ripple across the surface of the sun. They can actually be causing each other as these high-speed waves roll across the apparent real surface of the star. So right here in the southeast, So it's a shame we don't have stereo A and stereo B to help to calculate trajectories at the moment. They're both too close to the Earth to really be particularly helpful with that. And let's move to talking about filaments. Filaments. They are the things that go blasting off through space. We started out the video talking about them, and now we've come full circle. Filaments. There are a lot of them on the Earth-facing portion of the solar disk. Huge one up here, huge one, another huge one down here. That's a huge one too. It's very lengthy there. This one here is kind of big, and southern crown prominences also. So huge amount of material there suspended by magnetic fields on the Earth-facing portion of the solar disk. They're defying gravity. That's the El Teide, Spain, ground-based solar observatory in hydrogen alpha, 6,562.8 angstroms. There's also a crown prominence happening right now, and it's probably also associated with the CME. Looks like a lot of that material, if not most of it, is on its way out. This is the past about 2.5 hours from the GOES SUVI. And again, filaments are certainly the story of the day. So, even though you see sunspots degrading there and a little dip in the radio flux, there is certainly a lot of stuff going on, as you can see. Great imagery there. Also some activity happening here, down here. Definitely no shortage of activity. And thanks for leaving comments, Robert. Good morning. Next, our bonus features segment, starting with satellite charging hazards. It is clear sailing for satellites at the moment. No surface or internal charging hazards. The GOES electron flux here, kind of low. You can expect this to remain low. Actually, we should see a little uptick in it. Let's see what NOAA thinks after we show the one-year graph. So that's the last 3 days of the GOES electron flux. And there is the one-year chart, just to show you sort of an annual context for it. And there is the NOAA forecast, expecting a little uptick here. So I would agree with this one and this one, but not this one. So that in 3 days we'll have a very low electron flux again because of the coronal hole high-speed stream that I mentioned repeatedly earlier in the video. Next, we'll show the layer of the atmosphere where the electron flux is measured using radiography by the GOES 16 and GOES 18. It's the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation and other data shown there. There is a vibrational frequency of the bridge between Earth and space. So it looks like some significant low-frequency anomalies showing up here. Here is the anomalygram, depicting anomaly in megahertz from a 30-day median. We're seeing some rather coherent high-frequency anomalies there over West Africa and the Central Atlantic Ocean. Also Central Europe, Western Europe, North Africa. Seeing high-frequency anomalies there on the ionogram. That's anomaly in megahertz from a 30-day median, by the way. Low-frequency anomalies predominantly in the southern hemisphere, high in the northern hemisphere. That would be consistent with the approach of the solstice later this month. And let's bring up the latest images. There is 12:30 Universal Time ionogram and 12:30 Universal Time anomalygram. You can see those high-frequency anomalies. And let's also talk about the total electron content. If you're a GPS user, this will affect you, as your GPS must communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Those free electrons can cause signal refraction, and they do. Here is the forecast for your total electron content. It's literally a count of the free electrons to about 12,500 miles of altitude. And we're seeing some huge anomalies there in the southern hemisphere. So large electronic anomalies down here in the southern Indian Ocean, Southern Ocean, South Atlantic, just generally south of the equator there, lots of high electron contents. Some electrons, quote, out of place, end quote, causing some GPS errors in perhaps unexpected locations. We'll also show the North American total electron content anomaly. Now that we've showed the global view, there is the North American total electron content anomaly from the 10-day average. And you never know when data sets will have predictive value. So we just show it on the channel, as it may come in the future that we need to go back and look at these, because there has been data here logged that we didn't realize that we needed. We'll close out the daily space weather video section before we go to meteorology with our intensitygram and magnetogram. So again, here's this new sunspot. It's alpha class. It's got one South Pole oriented umbra. No, you know what? I changed my mind. It's beta gamma class. It's got barely a North Pole umbra there. You can see the blue behind it. It may even be trying to become beta gamma delta class. As far as this sunspot, it is beta gamma delta class, the most likely classification to produce a large solar flare. Again, we've got this sunspot here is pretty much just beta gamma class. There are a few deltas here, no major ones. Don't be surprised to see a big flare from up here. However, the most likely place to see a large flare, in my opinion, just remains this group right here. It is the most magnetically complex. It has the most deltas, the most unstable looking magnetic field shear. Anyway, continuing on, to remind our viewers to press the share button. Why? Because we're repeatedly discouraged by the pathetic, putrid, and disgusting censorship of big tech criminal organizations. Did you know that when somebody's video is demonetized, it's not just a problem that we don't earn money from ads playing? It's also a problem that the video doesn't get recommended. So this makes a lot of sense, right? Yesterday's top video on our channel had 1.4 thousand views and was demonetized for absolutely no valid reason. So this is why we need people like you to press share, comment, like, notify, etc. to join the Smash team and so on, because pathetic censorship is rampant, putrid, and frankly, it's encouraging us to quit making these videos, put them behind a paywall, and things like that. The story of the day is going to be smoke when it comes to meteorology. You'll hear it all around everywhere. This is the particulate matter, less than 10 micrometers diameter, and that's a lot of particulate matter. Also, the carbon monoxide levels are high. I did a 26-mile bike ride yesterday with a mountain climb. And if you want to follow things about fitness and diet, so on, posts that generally don't have much to do with space weather, make sure you follow us over on Instagram, as you'll see content that is exclusive to the Junkware platform. So here's the particulate situation. We're going to switch to surface winds as we roll through meteorology and give you the latest updates. So there is the surface wind scenario for the eastern world. Two powerful cyclones there, one west of India and one east of the Philippines. Here are the jet streams of the eastern world, like sands through the hourglass of time. These are the jet streams of your lives. By the way, if you know anybody who needs a voiceover actor, hit me up. I've got the goods. I want to be a cartoon villain or perhaps a horror movie villain. That sounds good. Here are the jet streams over the Americas, and the jet streams are incoherent over the U.S. and will remain that way. There's a huge divergence happening here by the Rocky Mountains, possibly caused by all the hot air coming out of Colorado constantly. There is also a powerful low here moving very slowly from Nova Scotia down toward Lake Ontario. That's what's pumping a bunch of cold Canadian smoke-filled air into the northeastern, the mid-Atlantic states, I'll say. And the forecast on yesterday's live stream came exactly true. I stated that a little break in the dry mass of air is going to cause more smoke to be funneled down, and the air alerts went to red and extreme overnight. Another forecast exactly right. No surprise, because if you understand the physics, you too can forecast your weather, whether it's space or Earth. Those are the surface winds. Here are the surface winds of the central world. Central Asia, Africa, and Europe. And these are the jet streams. Next, looking at drought intensity. So to make matters worse, as if it's not bad enough that we have all the smoke in Pennsylvania, check it out. The entire state is in extreme drought mode. Most of New York also most of West Virginia and half of Ohio. All of Ohio is in drought. Pennsylvania is all in extreme drought. It is way too dry. Please do a rain dance for us. The grass is getting crunchy, and it's pretty unfortunate. That is the drought intensity map. If you want to look at the moisture anomaly, there you go. Pennsylvania is, well, it looks like over 3 inches there below normal. Soil moisture is not so much. Not so much. Anyway, here's some satellite imagery of clouds and fog over Crescent Earth. And by the way, if you're flat Earth herp-derps on the internet want a photograph of the Earth, here's one. It's the NASA GOES Interactive Weather Satellite. Is it invisible light? Well, not at all. It's in infrared at 3.9 micrometers. Not visible to the naked eye. However, it does show clouds and fog at nighttime, so that's why we show it. And check out your weather alerts here. We've got some flooding, some flash flood watches over most of Montana, large portions of Idaho, and Washington. Also, air quality alerts, as I've stated. There is the key to show you a little bit about what the map is depicting. If your location is lit, head to weather.gov, and if you think mankind controls the weather, you have reached the pinnacle of ignorance and arrogance of physics. Next, our jet stream forecast. This is the 250 millibar winds, and the jet stream is going to remain incoherent for the next 3 days. That's a GFS 72-hour, 250 millibar winds, which is the jet stream. Effectively, it is a specific pressure of wind bands that show us the location of the jet stream. It's not going to end in the next 3 days, the incoherent weather pattern. So you'll see weird weather patterns continuing. It is caused by the influence or lack thereof of the jet stream. Next, your temperature anomaly forecast in degrees Celsius for the same model, the GFS 72-hour. It will remain quite cool, especially east of the Mississippi, and quite warm in the Pacific Northwest. Last but not least, your pressure and precipitation forecast, and you can see heavy storms there coming to Montana. A series of concentrated thunderstorms are in the forecast there. That's a GFS 72-hour pressure and precipitation forecast. And let's move on to lightning, because we don't want the video to be too lengthy. I mean, we did a cosmic ray report and so on today. Here's lightning. Some heavy lightning there forming off the coast of North Carolina. Please play. Please play. It's not playing because reasons. I'll press refresh. I'll try one time to get it to play, and there it goes. And that was the one time. Here's a real-time lightning map from blitzachtung.org. Quite a bit of lightning there in Central Europe. No terrestrial strikes in the U.S., apparently. Some around the Gulf, some around Central America. And by the way, this video does include paid promotions. So check out those. Help support the channel that way via the products below, linked in the video. So enter the promo code SMASHOMASH on checkout at Hemp Lucid, or shop via our link. Again, you'll find the link below this video in the description. You can also find it on our homepage at smashomash.com. Thanks to Hemp Lucid and everybody who's picked up products. Again, if you're in the market for CBDs, Delta 8s, mushroom gummies, etc., Shop via our link. Enter the promo code SMASHOMASH to save 10% on checkout. Thanks again, viewers. We've also added more new products to our Amazon shop. If you'd like help shopping for something on Amazon, drop us a line. However, we've already got a bunch of things that we're recommending, like spaceware, insecticide, which will not... How about insecticide that's edible? I'll just say that. These videos were also brought to you at massive personal risk and expense by Smash staff and I, which is why we were forced to create our own subscription services site. We needed further capabilities from Patreon, although we are still on Patreon. If you are contributing via Patreon, why not become a Smash Team member? You'll get additional content this way. Smashomash.com/Smash Team, launched in October of 2021 to bring you additional content. Thanks to the Gold and Silver Smash Team members, especially for making these videos continue to remain existent, publicly visible, and free for all to view. Smashomash.com/Smash Team. There's also a bronze level, and we do send out email alerts for certain types of things. So here's our smoke map. Click to refresh layers. All right, yeah, refresh them layers. So this smoke map is fire.airnow.gov. And those are serious smoke alerts there. Now, again, I did a 26-miler yesterday, including a large mountain climb, and my fitness has just recently turned a corner because, you know, fitness tends to get better in long, protracted waves, and that's just the way it happens. So I did a massive mountain climb yesterday, and I felt just fine. It was pretty smoky. The wind picked up massively, like halfway through the ride. That wasn't really the best thing because it was blowing me. It was blowing. I had a headwind on the way back. I'll just say that. But these weather alerts here in places like Reading, Philadelphia, these are the most extreme. Hazardous. It says at Reading Airport, avoid all outdoor physical activity. Yeah. So lots of people are delighted about the spooky, spooky smoke from Canada. They're out there wearing masks, thinking that that's going to work, you know, like those paper masks that people have been wearing. It's just ridiculous. Here's a U.S. Doppler radar map. It looks like some minor rain showers happening there in parts of Pennsylvania and New York. That's always a good thing. So, oh, and by the way, if anybody watching the video has a harp bass somewhere down here or something, turn on your harp bass and pull this low pressure system. Pull this low down to Pennsylvania and give us some rain. How about that? Does that sound good? Turn on your harp bass. Of course, I'm being facetious here, folks. Mankind does not have the capability to control large-scale weather patterns. Now that I've gotten that out of my system. Oh crap. I've done it. I got to reset the map, folks. Here's clouds and fog over the US. And here is water vapor. You can see that cold air blasting down from Canada once again. It was only like 50 degrees this morning here in Lehigh Valley, Pennsylvania, about 50 degrees Fahrenheit. And it looks like the Canadian smoke is going to continue to make its way down, so we'll continue to cover it. And we'll continue to cover your space weather in a detail absolutely unprecedented. We'll also show you solar imagery in detail absolutely unprecedented. So thanks for tuning in. Here's your recap. And by the way, consumer tip, when your Doppler radar map isn't making any sense, try looking at the water vapor map. If you understand atmospheric physics, you'll be able to forecast your weather. Anyway, thanks for tuning into the Smash News Network, least busted name in news. It's been a long time out of the bunker, and I've got to get back to the bunker, where I'll be safe from all this scary, spooky stuff in the sky. Ooh, look out, folks, the sky, it's full of scary, spooky stuff. So I'm headed back to the bunker. Whoa!